Hello children, how are you all? Hope you all are fine and doing well. Dear children, in a previous class, we discussed the sign convention rules and even we discussed what is a linear magnification and even we discussed the relation between power and focal length. In a today's session, we are going to solve the numericals based on the lenses. Children, before going to start the numericals, let us see what are the important formulas and what we have to remember actually so that we can do the numericals without confusion in an easy way, in a better way. Look at here. Children, here the first formula which we are going to use in order to solve the numericals, the first one is lens formula. The first one is lens formula. First one is lens formula, that is 1 by f is equal to 1 by v minus 1 by u. Children, this formula is used to find, means here three terms are there: focal length, image distance and object distance. So out of these three, if any two quantities are given, if two are either image distance or object distance given, then we can calculate the focal length. If these two are given, obviously the third one can be calculated. And children, this also can be written as like this, or we also can write like this: f is equal to it is uv by it is u minus v. Means whenever object distance and image distance is given, directly we can use this formula to calculate the focal length. Okay, fine. And the second one is linear magnification formula. That is, linear magnification can be written as v by u, or it can be m is equal to image height by it is object height. And even children, we can equate these two also. So most of the cases even we are going to use this formula also. V by u is equal to hi by it is h naught. Means here four variables are there here: v, u, hi, h naught. So out of these four variables, if any three variables are given, the fourth one we can calculate. And children, what information we get more about m is very important. Children, here linear magnification can be greater than 1, it is equal to 1, or it may be less than 1 also. So if linear magnification is greater than 1 means what? It is enlarged image. M is equal to 1 means, children, it is the same size, means image size is equal to the object size. If linear magnification is less than 1 and it is diminished, that is, the size of the image is smaller than that of the object. Means by knowing the m value, we will come to know that the size of the image. And even children, by knowing the sign of the m value, that is, if m is positive, children, if m is positive, then it is virtual erect. Virtual by default is erect only. If m is a positive, if m is negative, then it gonna be real and inverted. Which means what, children? Whenever in a question, a numerical, if it is asked to write the characteristics of the image, then we have to use this formula, and we, based on the value and based on the sign, we will decide what are the characteristics, whether it is a real, inverted, diminished or enlarged. So these kind of things will be there. So those are decided based on this data only. Okay. Then we discussed about power and focal length, children. So power is equal to 1 by f, but here f is measured in meters, or we also can use here power is equal to 100 by f, here f is in centimeters. So children, these are the formulas which we are going to use in order to solve the numericals. Then here we get a wonder, sir, are these formulas enough to solve the numericals based on length? Means no. Why? Because the very important thing is what actually sign convention. Children, these formulas plus sign convention rules, then definitely means by keeping this what we can say formulas, if you apply the sign convention rules, definitely we will do the numericals very easily. So once again, let us see what are the sign convention rules in a fast manner. Children, these are sign convention rules, these are same, either it means same for even mirrors, lenses. it might be convex lens, concave lens, convex mirror, concave mirror. These sign convention rules are same only. So what are those? Let's look at here. Means with these sign convention rules, we will come to know that which distances can be taken positive, which one can be taken as a negative also. For suppose dear children, here is convex lens is there. For example, I am telling you, just example. So according to the sign convention rule, dear children, the optic center of a lens, optic center. In the case of a mirror, we can talk about the pole. Pole is considered as the origin, but whereas as we are discussing about lenses, so here optic center is considered as the, what we can say, considered as a what? Origin it is. Okay. Now dear children, means what? All measurements, horizontal measurements must be taken from the origin only. And children, here object is placed left side here like this. Then what will happen? Incident light rays will go like this. Children, this is here, incident ray is a reference to us. Incident ray is a reference to us. Object is formed here. Object is placed this side. So that now light rays are going right side. Now if I want to measure object distance, so from here to here I have to measure. Means in opposite direction I have to measure here. Look at here. Here it have to measure. So means I must start from O. Okay, na? I must go towards the object like this. But light rays are going right side. So U is taken as a negative here. U is taken as a negative. And the children, these light rays are coming like this. And here after refraction, they will go like this. They will pass like this. And this is actually focus. And this is going to be focal length. If I want to measure the focal length of a convex lens, dear children, so again we must start from the optic center only and we have to move towards the focus. But now, dear children, so light ray is going right side only and we are also moving in the direction of incident ray. So here focal length is positive. Focal length is positive. Focal length is positive. For somehow, dear children, then you may get one doubt actually. Sir, if somewhere image is formed here, okay. Image is formed here. Let us say image is formed there. So this is going to be image distance. Then image distance, will it be positive or a negative? So children, again I am saying we have to start measuring from optic center only. So from here we have to start. Let us measure its distance here. Means we are measuring in the direction of incident ray only. So here V is positive. V is positive. So U is positive, V is positive. What is the object height? Above the principal axis, children, above the principal axis is the object height, always taken as a positive only. So its heights below the principal axis are taken negative, Then you may get a one doubt, sir, it is a real image case. If virtual image case means what? Children, whatever may be the case. For suppose here image is formed somewhere else here. With the convex lens image is formed. So this will become that type image distance. Yes, let us measure from optic center we have to start, move towards the image. So are we going in the direction of incident ray or opposite? Opposite direction. So that time image distance will become negative. Then children, here you may get a one doubt. Sir, is it compulsory that object must be placed left side of the lens only? Means actually no, dear children. So of course, up to 10th standard, whatever the cases which we are taking, in all cases we will place, means by default object is placed left side only, but it does not mean that object must be placed left side only. It can be placed left side and it can be placed even right side also. Means when you go for higher classes, this point is discussed. Now let us check. Here you may get one doubt actually. Sir, when object is taken left side, so that we got a focal length negative, focal length positive, object distance negative, then how it will get affected if at all object is placed right side, Let us see that also, so that whatever the confusion which we have, that will go. Okay children, look at here. Now let us take a case, same case everything children. Here is, okay, it is optic center only, fine. Now before we place object left side, now let us try like this. Now object is placed right side. Now children, see whether object is placed left side or right side. Incident light rays are taken towards the lens because they have to form the image, right? So now this is actually in this direction incident ray will be. This is incident ray direction. incident ray direction. Fine. Now let us measure the object distance first. So object is placed here. It is the optic center. So we know that, dear children, optic center is origin from where we have to start the distance. Means here, from here to here, now I want to measure. So to measure, I am going towards the object. Am I going in the direction of incident ray or opposite? Obviously opposite only. So whenever the distances are taken opposite direction of the incident ray or negative. So here object distance is negative. Fine. So no change in it, nothing. Fine. Now let us say here light rays are coming like this, so that after refraction, so this point is going to be focus and this will be the focal length. This is the focal length. Now I want to check whether convex lens, in the previous case we got a positive. Now in this case, whether we are going to get positive or negative. Look at here. So children, this is a point from where we have to measure. Till here we have to measure. So let us move optic center to focus like this. So don't you think that we are moving in the direction of incident ray? So children, the measurements taken in the direction of incident ray are positive. So here focal length is positive. Focal length is positive only. Now here somewhere, look at here, image is formed here. So this is going to be image distance. This is going to be image distance. Then is image distance positive or negative? Children, again it must be measured from the optic center. From here, let us move towards the image position like this. So again we are going in the direction of incident ray only. In the direction of incident ray only we are moving in order to measure the incident, what we can say, image distance. So image distance is positive. And as we discussed, the measurements taken above the principal axis are positive. Okay, positive only. And the measurements taken below the principal axis are negative. So it is negative only. If let us take the convex lens with a virtual image case. So virtual image is from this side, somewhere else. If, okay now, then this is gonna be image distance. If you want to measure this image distance, from here we should start and we will go towards this one. Then we are going opposite direction. Incident ray is going like this. We are going in this direction. So if it was a virtual image case, that image distance will become negative. Now children, check here. Are there any changes? There are no changes at all. Children, whether you keep object left side or right side, it is not at all a matter. Here the thing is that rules are very, very important. What are those? Children, again I am saying you. Of course, according to, up to 10th standard, as I am telling you, in all the cases, object is placed left side of the lens. It does not mean that object must be placed left side only. It can be placed left side, it can be placed right side also. Whatever it may be the place of the object, sign convention rules are same. Apply the sign convention rules. What are those? The distance means, according to sign convention rules, distances measured, especially horizontal distances measured from the optic center, and the distances measured in the direction of incident ray are positive, and the distances measured opposite direction of the incident ray are negative, and the distances measured above the principal axis are positive and below the principal axis are negative. So children, according to the sign convention, the focal length of a convex lens is always positive and the focal length of a concave lens is always negative. So children, so these are the sign convention rules which we are going to apply to the numerical, so that we will be solving the numericals in an easy manner. Now let us start with the first numerical. Let us do the first numerical. Children, you can see the numerical on the screen also. So what actually given according to the numerical, dear children, here is a convex lens. So in front of a convex lens, the object of height, here object is given, the object of height 3 centimeters is placed such a way that image is formed on a screen, such a that image is formed on a screen. So this image is placed 30 centimeters from the lens, and here object, let us say this object might be some candle like this, so that it's like a candle. So image is formed on the screen, children. So here image of the candle is formed. Let us say here image of the candle is formed. Let us say here is an image, and the height of this image is 6 centimeters. So in order to get the image of height 6 centimeters at a distance of 30 centimeters, then where the object of 3 centimeters height must be placed means we need to calculate the object distance, then we need to calculate even focal length also. So first write the data, and children, whenever we are applying the whenever we are substituting the values, so we must follow the sign convention rules. That is very important. Okay, na? So according to sign convention rule, dear children, first what is given here? Object height is given, it is going to be positive 3 centimeters. Image height is given, it is negative because real image and image is found below the principal axis. So it is minus 6 centimeters. And image height, image distance, so from the right side, that is in the direction of incident ray, it is taken 30 centimeters. So first we need to calculate the object distance, then we can calculate the focal length here. So children, we have a relation V by U is equal to HI by H naught. So from this we can make a U as a subject, U as a subject. So U is equal to V into H object, that is the height of the object by height of the image. Children, we have to substitute the values with the sign convention. That's very, very important. Okay, look at here. V value is given 30, H naught is given 3, and it is a minus 6. 6 1 ja, 6 5 ja, 5 3 ja, 15. So here U is equal to minus 15 centimeters only. Children, object distance always negative only. Whether it is given in a question, we'll take it as a negative only. So we need to calculate also, we must get here negative only, because object distance is always measured in the opposite direction of the incident ray only. Okay, fine. This is object distance, first question. Now even they are asking us to calculate even the question, dear children, focal length also asked. So how to calculate the focal length? Look at here, focal length formula we have 1 by f is equal to 1 by v minus 1 by u. 1 by v minus 1 by u. So from this, dear children, let us substitute the values here. 1 by f is equal to 1 by v is 30 minus u is equal to minus 15 we got. Children, don't forget that. Here minus into minus, it is going to be plus. So it is 1 by 30 plus 1 by 15. So let us see here what we are going to get here. So here 1 by f is equal to, let us take here LCM is going to be 30. LCM is going to be 30. So it is ones 15 twos. So children, it is 1 by f is equal to 3 by 30. So it is 1 by 10. So f is equal to, we got 10 centimeters. Children, here we got a positive value because it is a convex lens, and we also know that the focal length of a convex lens is positive only. So we must get positive only. So here we got f is equal to 10 centimeters. So this is how. Children, look at here. Again I am telling you, so we need to substitute the values with the sign convention. Accordingly we have to substitute. In the place of minus 6 centimeters, if you substitute 6 centimeters, okay, you may follow the correct procedure only. But the thing is that you don't get a correct answer here. U value will get wrong. Obviously, f value also you are going to get wrong. Okay, fine. This is the first numerical. Now let us move to the second numerical. In the second numerical, children, what is asked? Look at here. In the second numerical, it is given that here is a concave lens. Here is a concave lens. In front of a concave lens, children, an object is placed. An object is placed here at a distance 20 centimeters in front of it, a convex. Okay, na? An object is placed in front of a concave lens at a distance of 20 centimeters, such a way that an image is formed in front of it, I mean the same direction, the same side, at a distance of 10 centimeters, a distance of 10 centimeters. Obviously, we know very well, wherever you can keep the object, dear children, image is always formed between object and lens only. And here they are asking the characteristics of the image form and the focal length of the concave lens. So children, first let us calculate the focal length. So here, according to the question given, dear children, here u value is going to be minus 20 centimeters and the v value is going to be minus 10 centimeters. Children, in this case, children, in the case of virtual image, obviously we get u is a negative and v also negative only. Now how to calculate the focal length? Same formula, 1 by f is equal to 1 by v minus 1 by u. So let us apply this here. 1 by f is equal to 1 by v minus 1 by u. So same lens formula which we are applying. So look at here, 1 by f is equal to, Children, we are going to get a negative value only. Why? Because it's a concave lens. For a concave lens, the focal length is a negative. Okay. Let us substitute here. It is minus 10 minus of minus 20. Children, you must be very careful when you are substituting the values. Okay. Fine. So, this is going to be minus 1 by 10. So, minus into minus plus this is 1 by 20. Children, here LCM is going to be 20. So, 10 twice it will go and it is a 1. This is minus 1 by 20. Children, here 1 by f is equal to, we got minus 1 by 20. So, here f is equal to minus 20 centimeters. Children, as it is a concave lens, its focal length is negative only. But children, what are the characteristics of the image formed? So, let us here, as in a numerical they did not ask us to calculate what we can say magnification. Let us try here. Children, we know that magnification is equal to V by U. V by U. So, V value is how much we got here? Minus 10 centimeters is given. U is minus 20. So, this is going to be 1 by 2, that is 0.5. 0.5 means what, children? Here m is less than 1. Okay. And here we got m as a positive. M as a positive. Children, if m value is less than 1 means what? It is diminished image. It is diminished image, obviously, and m is positive means obviously it is a virtual. Children, for a virtual image only, linear magnification is a positive. Virtual, and by default it is erect only. Children, just to write the characteristics of the image form, you don't need to do the numerical only, because it is a concave lens. Obviously, always concave lens forms diminished, virtual, erect only. Okay, na? So, this is how actually, if they will ask us to calculate even the magnification in this case also, this is how actually we have to follow. Okay, just copy it. That is the third numerical. Children, here is given, here is a convex lens of focal length 25 centimeters. 25 centimeters. So, they are asking us to calculate the image, means where we need to keep in front of a convex lens an object, so that we get virtual image of twice the size of the object, virtual image. So, we are going to get, so we need to calculate the object distance. So, where are we going to place the object, so that we get, with a convex lens, we get virtual image and double the size as that of the object. So, children, for suppose the object size is x, let us say. So, then it is going to be 2x, it is going to be 2x. So, to get such a image, so where the object is placed. So, children, according to sign convention here, the focal length of convex lens is positive, that is 25 centimeters, and here object height is going to be positive plus x, image height is going to be 2x. So, children, from this we can calculate the magnification directly. So, magnification we know that image height by object height is equal to 2x by x, x cancel. So, magnification we got, it is 2. Children, look at here, here we got m is greater than 1 means it is a enlarged image, no doubt about it. Convex lens gives enlarged image only in this case, and it is a positive means virtual. So, virtual and enlarged is given by convex lens only. Fine. And we also know that, dear children, m is equal to v by u. So, let us substitute here, m value is 2 and it is v by u. So, children, from this we can write v is equal to 2u, v is equal to u. So, children, here we have f is equal to 25 centimeters, here v is equal to u. So, by using these two, we are going to calculate the u value. How? Lens formula let us take. Again, let us take a lens formula. 1 by f is equal to 1 by v minus 1 by u. From here, children, 1 by f. So, 1 by f value is given 25 and it is 1 by v is equal to, it is 2u minus 1 by u. So, here let us take a LCM. 1 by 25 is equal to, LCM is going to be 2u, that will be 1 minus 2. This is going to be minus 1 by 2u. Children, 1 by 25 is equal to, look at here, we got here 1 by 25 is equal to, we got minus 1 by 2u. So can we write like this? 2u is equal to minus 25. Yes, we can. So u is equal to minus 25 by 2. So 25 by 2 is 12.5. So u is equal to minus 12.5 centimeters. So children, we should keep the object in front of a convex lens of focal length 25 centimeters at 12.5 centimeters so that we obtain virtual image with double the size than that of the object size. Okay, just copy it. Now, just look at the fourth numerical. Children, fourth numerical is similar to the third numerical, but small difference is there. So, it is given that, children, here is convex lens. Its focal length is given 0.12. Now, where this object is placed, children, where this object is placed, so that we get the real image only, but 3 times greater, means the size of the image which we are going to get is 3 times than that of the object. So, the difference is that in the previous numerical, the image size is twice than that of the object size, but the thing is that it is a virtual image. But this is a case of real image and the image size is 3 times than that of the object size. So, somewhere else here image is formed. So, let object distance is, object height is x, then image height is going to be 3x. Image height is going to be 3x. So, here according to sign convention, object height is going to be x, image height is going to be minus 3x. Image height is going to be minus 3x. And we know this relation, right? What is that? V by u is equal to hi by h naught. So, from this, children, here v value is not given, u value is not given. So, image height is minus 3x and object is x cancel. So, v by u is equal to minus 3. So, here v is equal to minus 3u. So, children, here we have v is equal to minus 3u and the focal length of the convex lens is positive and is given 0.12 meters. It is 0.12 meters. So, these are the two values which we are going to use to calculate to find the object, means where object must be placed, so that we get the real image and 3 times the size of the image is 3 times than that of the object size. So, again let us use the lens formula here. What is the lens formula here? 1 by f is equal to 1 by v minus 1 by u. So, formula which we are going to use. Let us substitute the values. 1 by 0.12 is equal to, children, here because the decimal number is there, no need to write a 12 by 100, don't simplify, just keep it as usually, just you follow the steps, you will get the answer. So, it is 1 by 0.12 by 1 by minus 3u minus 1 by u. So, this is going to be 1 by 0.12. So, this minus will go to the numerator. So, children, anyhow LCM is 3u, this is minus 1, it is minus 3 it is. So, this is going to be minus 4 by 3u. Children, 1 by 0.12 is equal to minus 4 by 3u. Let us do the cross multiplication. Then we get like this, or else just let us write one more step. 1 by 0.12 is equal to 3u. Do the cross multiplication. So, what do we get here? 3u is equal to minus 0.48. So, u is equal to, you get minus 0.16 meters. 0.16 meters. So, we got negative only. So, children, this is how we should solve. Children, this numerical 3 and numerical 4 both are similar numerical only, but the difference is that in the third numerical, here it is a virtual image case, whereas in this case it is a real image case. The thing is that actually whatever may be the numerical, so we must be very careful with the sign convention. Okay, just copy it. Fine, children, here is question number 5 here. It is given that the children here is an object. Let us put an object and this is a screen where image is going to be formed. So, let us say this is illuminated object, such as candle. It is, here is a candle, it is an object, and the distance between object and screen, object and a screen is 1 meter, that is 100 centimeters. 100 centimeters. So between object and a screen, a lens is arranged, convex lens is placed. Convex lens is placed such a way that this distance is given 75 centimeters. Then they are asking us to calculate the focal length and a magnification. Children, if this distance is 75 centimeters, obviously object distance is going to be 25 centimeters. Object distance is going to be 25 centimeters. Now let us write the data given according to this. U is equal to minus 25 centimeters and V is equal to minus 75 centimeters. And we need to calculate initially focal length. We need to calculate initially focal length. So let us use the lens formula. 1 by F is equal to 1 by V minus 1 by U. Substitute the values with sign. This is 1 by F is equal to, what will happen? 1 by V is minus 75. So image distance, children, it is measured in the direction of incenter. It is a positive only. So it is a positive. And a minus 1 by minus 25. So look at here, 1 by F is equal to, children, here minus to minus plus. So it is 1 by 75 plus 1 by 25. So here LCM is going to be 75, it is ones, 25 threes. Okay, so this is 4 by, it is 75. So 1 by F is equal to 4 by 75. So here F is equal to 75 by 4. So how much do you get? It is 4 ones, 4 eights, 4 7 and 5 centimeters. So here the focal length of a convex lens given according to the numerical we got as a 18.75 centimeters. Now even they are asking us to calculate the linear magnification. Children, here second one, linear magnification, we know that it is given as V by U. So it is M is equal to V by U. So let us substitute the values here. M is equal to, V is how much, dear children? It is 75 centimeters by U value is how much? Minus 25. Minus 25. So here we get as a M is equal to minus 3. M is equal to minus 3. Children, here we got 3 is what here? Greater than 1. So M is greater than 1 means what here? It is enlarged image. It is enlarged image. And M we got as a negative, which means what? It is real and it is inverted. Real and inverted. So this is how we can calculate the focal length and magnification of a given lens. So next, in a question number 6, children, it is given that here is a lens, okay, and let us say principal axis and its optic center. So in front of this lens L, and it is not mentioned whether it is a convex lens or concave lens, it is not mentioned. Here is an object is placed at a distance 15 centimeters in front of it, such a way that a virtual image is formed in front of it only at 60 centimeters. At 60 centimeters. Then find the focal length of the lens and write the characteristics of the image formed. Children, just logically you think, if it was a concave mirror, then image might have formed in between object and a lens. Here what happened? Image is formed here same side only, but not between object and optic center. So definitely it is a convex lens only. So here is, it is a convex lens only. It is not a concave lens. So this is how actually we can come to the conclusion regarding the lens what actually given. Now according to sign convention, dear children, here U is equal to minus 15 centimeters, V is equal to minus 60 centimeters. Then we need to find the focal length. So again we are going to use the lens formula, that is 1 by F is equal to 1 by F is equal to 1 by V minus 1 by U. So this is the formula which we are going to use. Okay, here it is 1 by f is equal to, that is 1 by minus 60 minus of minus 15. Children, here minus of minus, it will become minus and minus, it will become plus. So this is minus 1 by 60 plus 1 by 15. Then children, here LCM is going to be 60, then 60 ones, 15 fours it is. So this is 3 by 60. 3 by 60 will become 1 by 20. Therefore, focal length we got 20 centimeters, and here we got a positive. For a convex lens, focal length is positive only. Now let us read the characteristics. Children, characteristic means mainly what here? The size. If you want to know the size, you must know the magnification here. So this is first one is focal length, second is magnification. Magnification is equal to V by U simply in terms of image distance and object distance. Here substitute the values. V is minus 60 by it is minus 15. Minus cancel, 15 ones, 15 fours. So here we got M is equal to 4 and it is positive also. M is equal to 4. So linear magnification is 4, which means what? Image size is 4 times greater than that of the object size. And here M is greater than 1 as we know. So it is enlarged and 4 times greater, enlarged 4 times greater, and as it is a positive, is a virtual and erect only. Okay. So this is how we have to. But the thing is that, children, here in the question it is not mentioned whether it is a convex lens or a concave lens, with the given data only. So we have to think and we have to go for that it as a convex lens only. Now look at here. Next, moving to question number 7. Question number 7. So in this numerical also, dear children, here is a lens. Here is a, let us make it as a, here is a lens L, and here is principal axis. It is given that an object is placed in front of it at a distance 45 centimeters. 45 centimeters, such a way that image is formed at a distance 90 centimeters, but not in front of it, rather other side of the lens. So here other side. Children, it's very clear that if it is a virtual image means form same side of the object. Real image only form other side of the lens, and we know the real image is inverted. So this side it is, here is. So this is given as 90 centimeters. It is given as 90 centimeters. So with this information, it's very clear that given lens is what? It's a convex lens only. Because concave lens, no chance of forming real image. Concave lens always forms virtual image, whereas convex lens forms only real image. So this is gonna be convex lens. So this is how actually we have to think. Here is convex lens. Now let us apply with a sign convention. Let us read the data what actually given. Children, object distance is given minus 45 centimeters. 45 centimeters given and it is a minus. Okay now, because light rays are going like this, so that we will measure here to here, means in opposite direction, taken as a negative only. And image distance is 90 centimeters. Now we need to calculate the focal length. Apply the same. Here, where is that? Lens formula 1 by f is equal to 1 by v minus 1 by u. So here 1 by f is equal, let us write once again, 1 by v minus 1 by u. So this is a formula which we are going to apply. So here 1 by f is equal to 1 by 90 minus of minus 45. Here minus into minus, it is going to be plus. And this will be 1 by 90 plus 1 by 45. So LCM you can take it as a 90. LCM is 90. So it is 90 ones and 45 twos, and this is 3 by 90. 3 by 90 is 1 by 30. So as it is 1 by f is equal to 1 by 30 children, then f is equal to 30 centimeters. See here, as it is a convex lens, so we got here plus. The focal length of a convex lens is a positive only. Now magnification, let us, it is not asked, but let us try magnification, because it is asked to write the characteristics, right? So obviously here you have to write, look at here. So m is equal to v by u. V is equal to how much we got? 90 is given, sorry, and it is a minus 45. So here m is equal to minus 2. M is equal to minus 2. Children, as m is 2 means what is greater than 1? It is a greater than 1 only. So it is m is greater than 1. 2 means. So obviously it is a enlarged image, enlarged one, and here m is negative. M is negative. So it is real and inverted. Real and inverted. So this is how we have to. Children, the specialty of these two numericals is that they did not mention whether the convex lens or a concave lens. Only data is given. Based on the data only, we came to know that it is given one is a convex lens. Okay. Now numerical 8. Children, clearly it is mentioned that given lens is a concave lens, especially in this numerical, and here is concave lens is given. The children, and its focal length is given 20 centimeters. Focal length of a concave lens is given in the question is 20 centimeters, and an object is placed at a distance 20 centimeters in front of it. 20 centimeters in front of it. Then we need to find the position of the image, and we need to find the even characteristics. Now let us write the data. So according to the information given to children, and by following the what sign convention rules here, the object distance is minus 20 centimeters, and the focal length of a concave lens is always negative. So it is a minus 20 centimeters only. Then we need to find the image distance first, then characteristics. So here we are going to use 1 by f is equal to 1 by v minus 1 by u. That is a lens formula only we are going to use. Okay. Now look at here. So here 1 by, substitute the values, minus 20 is equal to 1 by v minus, here u is minus 20, don't forget that, minus 20. Children, minus of minus plus it is, so it is 1 by v plus 1 by 20. So here 1 by minus 20 is equal to 1 by v plus 1 by 20. Now let us rewrite like this. 1 by v is equal to minus 1 by 20, and when this plus 1 by 20 is brought left side, then it will become minus 1 by 20. And here LCM is common, it is a 20. So it's a minus 1 only. So 1 by v is equal to minus 2 by 20. So this is minus 1 by 10. So 1 by v is equal to minus 1 by 10, and obviously here v is equal to minus 10 centimeters. Minus 10 centimeters. So children, image distance we got as a negative, which means what here? Image is from left side only. That too 10 centimeters means here is focal length is, for example, let us say there only it is a focus. So this is a focal length. This is a focal length what actually given. So image from 10 centimeters means here image is found. Means it is a virtual image only. It is a virtual image, no doubt about it. But is it enlarged image or diminished image? How can we tell that? If we can calculate only magnification only, we can say whether the image so formed is a diminished image or enlarged image. Let us see the children. So here linear magnification is equal to, we know there is a v by u, but v got as a minus 10 and the u is minus 20. So this is gonna be 1 by 2, that is m is equal to, we got 0.5. That we got as a positive only. Children, m we got as a 0.5 means what here? M is less than 1, which means what it is? Diminished image only. So it is a diminished image. So by knowing v value, I mean sign of the v, or sign of the m, we will come to know that whether it is a real image or virtual image. Children, here m is a positive, so it is a virtual image only. So virtual and diminished image. So virtual and diminished, that's it. So virtual and diminished image. So this is how actually we can solve. Okay. Now here numerical 9 children. Here it is given that the power of a lens is given as a plus 2D. Plus 2D. D means what here? Diopters here. So power is given plus 2.0, that is 2D only. Then it is asked to find the focal length of that particular lens and its nature also. Okay, no? Fine. Children, we have a relation. What is that? P is equal to 1 by F, it is in meters, or P is equal to, it is 100 by F, it is in centimeters. Children, either you can use this or this, but the difference is that when you use this formula, you get focal length in meters. When you use this formula, you get focal length in centimeters. Everything is fine. Now look at here, let us follow this here. So from this, F can be written as 1 by P, and it is 1 by 2, obviously it is a 0.5 meters. 0.5 meters. Okay. Now let us try this. So with this, focal length is equal to 100 by P, and it is 100 by 2. So it is 50. So F is equal to 50 centimeters. So nothing makes different. And children, it is power is given as a positive, and obviously we are getting here focal length also positive only. No need to write, but it's a positive only. Now you tell for which lens focal length is a positive, and it is none other than it is a convex lens only. So the given lens, the nature of the lens is convex lens. Convex lens. Convex lens. Okay. Now, question number 10. Actually, it is given that a focal length of a concave lens is given as a 20 centimeters, and it is asked to calculate the power along with the sign. So, children, for a concave lens, the focal length is always negative. So, here F is equal to minus 20 centimeters. Minus 20 centimeters. And here F is given centimeters. Let us use this formula only, so that it is very easy to us, convenient. Okay. So, then P is equal to 100 by, it is F actually. So, let us substitute the values. It is 100 by minus 20. So, minus 20. So, here power is equal to how much we are getting, obviously 21s are 25s are. So, we are getting a minus 5D, that is the diopters. The diopters. Okay. Now, question number 11, dear children. So, it is given that a focal length of a convex lens is 25 centimeters. So, that is F is equal to, as it is a convex lens, children, its focal length is positive only. So, it is a plus 25 centimeters. Then we need to find the power. We need to find the power. How can we find? So, here it is. We know that P is equal to, same formula, 100 by F. So, it is 100 by 25. 100 by 25. So, P is equal to, it is plus 4 diopters. Plus 4 diopters. So, this is how actually we can solve the even numericals based on the focal length and power. So, children, these are the numericals based on convex lens and a concave lens. So, children, to get the numericals in a perfect manner, to do a numerical simple manner here, the formulas, especially lens formula, 1 by F is equal to 1 by V minus 1 by U, and the linear magnification formula, and the formula that is a relation between power and focal length. Along with these formulas, dear children, you must have a knowledge of sign convention rules. So, this formulas plus sign convention rules. If these things are in your mind, definitely you can do the any type of numerical based on lenses. Okay, children, thank you so much. All the very best.